Hello everybody, my name is Steve Kaz and I'm a data scientist who's just recently graduated from Florida Polytechnic University. Today I'm going to be going over my hospital readmission data warehousing project where I used BigQuery, SQL, and Tableau and some Python to analyze why or what the main reason for hospital readmissions are, and a few business questions. So getting into it, the project overview, we are doing a hospital readmission analysis. The goal is to improve patient outcomes and reduce costs. We are building a data warehouse using star schema and BigQuery, which is on a Google Cloud platform. This is what our resource stack or tech stack look like. For our ETL pipeline, we're going to use Python. For our data warehouse itself, we're going to use BigQuery. And then for the visualizations, we're going to use Tableau to display them and then Python to clean up the files. So for our data set, this would be the raw layer. It's a Kaggle data set. It has 17 attributes and 25,000 observations. Some example attributes are time in hospital, procedure numbers, and specialties. And here are a list of the different variables. For our beam, which is business understanding, explore, analyze, and monitor phases, our business understanding is to improve a hospital decision making by creating a data warehouse with readmission info. Our explore phase is to identify any limitations or challenges. Our analyze phase is to the bronze, silver, gold level to ultimately reach our star schema with analytical tables. Monitors to ensure business needs are met while ensuring data quality and integrity. So our 3 business questions. What is the overall readmission rate? How does it vary by age and length of stay, or LOS? Which diagnosis categories have the highest readmission risk? How does procedure intensity and medication complexity correlate with readmission? The 7 whys that we asked, for who, it was the people who were mainly getting affected by it. The what was a data warehouse. The where was the Kaggle data set, which would be stored in BigQuery. The when was the analysis. That included historical data and trends and support ongoing monitor of readmission patterns. The why is to reduce hospital readmissions and improve operational quality. The how was to build an ETL pipeline, create a star schema, and use SQL to analyze. So for our EDA, our exploratory data analysis, we had no missing values. The readmitted amount includes about 13,246. This is the readmission distribution. For people who didn't readmit, it was around 13,000. For the people who did, it was just about under 12. Moving on to our bronze, silver, and gold pipeline. For bronze, we preserved the raw data with just ingestion metadata. We applied 4 transformations. We mainly, when we were cleaning the data and going through each phase, we made sure to make a previous copy. So, for instance, we would have bronze data layer, and then we would have a silver, and then we have a gold, and then we would have our BigQuery, which is what we imported into BigQuery. And then we take that data set after importing into BigQuery and connect to Tableau. For our silver pipeline, we did some data cleaning and transformation phases. We initially transferred age to a numeric midpoint, but we decided to revert that after our proposal, as I feel like the ranges were a better determination for the graphs. For validation, or for flags, we converted yes, no to 1 and 0s. Validation, we removed invalid time in hospital, so like less than 1 sec, or less than 1 or greater than 30. Missing values. So there were technically missing entries as a category, but not as a bad entry. So for instance, for diagnosis 1, 2, and 3, there could be diagnosis for 1, diagnosis for 2, but in column 3 there could say missing, which just means they didn't take a third diagnosis. So we did some feature engineering and came up with these respectable features. And the feature engineering allowed us to basically just better understand the readmissions and better assess our business questions so that we could get to the point of answering them. This is our warehouse design overview. It was a fact table, one fact table, four dimension tables. The fact table was fact underscore readmission. One row per hospital encounter was the grain. We had dim patient, dim diagnosis, dim time, and dim encounter. Patient was for the demographic insights. Diagnosis was like medical conditions associated with encounters such as diabetes, muscular, skeletal, other, or respiratory, and a few others that are not coming to the top of my head. Dim underscore time, which is length of stay categories or LOS. Dim encounter was more the clinical activities and resource utilization during the encounter, such as like what tests were done, was there change. That's pretty much it. The rest of the more generic qualities were in the fact table. We're going to pivot now to the actual fact table or data warehouse star schema. So this is what the table looks like. We have the fact readmission in the middle. Then we got patient, diagnosis, time key, and dim encounter with all their respective primary keys. And then in fact readmission, we have the primary keys and foreign keys. So for encounters, as I mentioned, it was the number of outpatients, number of inpatients, number of emergencies, different tests. Was there change? The diabetes medicine, was there medication for diabetes? And then those were connected to readmission. Same thing with diagnosis. There was 8 different codes, 8 different categories. Patient was more so about the person themselves. What age group do they fall in? What was their age numerically? What was their age? Or age numeric was more so the midpoint, I believe, that the patient fell under. And then if they were current, moving on, we're going to go back. I forgot. I included it in the presentation as well. I just think it was better to see in the picture form, as you can see kind of the lines better. So now we get into our SQL queries that we did in BigQuery. So this is my BigQuery. I'm going to go back. We made our hospital readmission data warehouse. Then within it, we have our fact readmission, our different dim tables. This is our readmission table and all the features that were listed in the star schema. Then we got dim time, which only has the 2. Then we got dim patient, which has all of them as well. Dim encounter, and then dim diagnosis. And then they all have data in them. I probably should have showed that, but these are the different diagnosis keys. I'm going to go back again and showcase what all of them, this is what I meant to do, what all of them look like. Originally I had time in hospital here, but ended up removing it as it was just a duplicate of the time key, which I didn't seem was very useful. Then we go to patient preview. Then we got the age groups, the midpoint numeric. Then we got encounter. And this kind of has everything. The reason glucose test and A1C tests were changed to 1 and 0 is because they were on different measurements. It was no test, normal, high, I believe. There might have been a low, but I don't think there was. And then I already showed diagnosis. So that's that. Now we're going to move on to our SQL queries. So for now that you've seen the tables and what they look like, these are the queries that we use to make them, or make our graphs for our dashboard. So our first one is readmission by age group. This is the age group, which is like the range, and just see what the highest readmission rate is. I will show the visuals at the end here. Then we have readmission by diagnosis using SQL query, and then you can see the results at the bottom from what has the highest readmission rate. It is worth mentioning that in line 7, if you were to also join diagnosis key, or secondary underscore diagnosis underscore key, to make it equal to the diagnosis key, you would the readmission rates would jump up. Like diabetes would jump up to 69.9%. So I thought that was very interesting, as you could see, like overall who's getting diagnosed instead of just who's getting the first diagnosis or primary. Then we got readmission by length of stay, just to see how long people were readmitting after their stay, or depending on how long they stood, which wasn't that big in disparity, as long was 49.6, medium 49.3, and then 44.3 for short. For prior visits, one of the risk factors that we wanted to analyze was, depending on their length of stay, how likely are they to come back. After 6+ visits, you're 79% chance of readmitting, which I thought was very interesting, out of 4,000 encounters at least. Then we have medication complexity versus readmission percentage. This is the medication complexity, whether it was high, low, medium, or very high, and then the readmission rate based on that. And then we have our key performance indicators, which is total encounters, total readmissions, and readmission rate, and then the average length of stay. This is what our dashboard looks overall. Starting from the top, starting from the top, you have the key performance indicators, the main point of this dashboard, just to see, like, at a quick glance, oh, so what is the readmission rate? Bam, it's at the top. What is the average length of stay? Bam. How many encounters was this data set? How many readmissions? Now looking at readmission rate by age group, which is on the left side here, you can see that the 80 to 90 range was 49.43%. You could also see the length of stay. Long had the highest readmission rate. For readmission by diagnosis, it was 54.5% with diabetes, and then respiratory at 50%. For medication complexity, it was kind of interesting, as at the bottom, if you could see, it goes from very high, medium, low. We're just organizing it by complexity level, and that high was actually the highest in comparison to very high. My theory on this is that when somebody is so ill or sick or hurt to the point that they're dying almost, their readmission, or they're going to be attended to quicker or more effectively than if somebody just has a high case but isn't like life-threatening. So for instance, the example I could use is like cancer. Cancer is a very high medication complexity. The reason they want them to keep readmitting, though, is to keep getting more money over time. Whereas if they were dying from cancer, they'd probably give them more of an antidote to cure them, but not cure them 100%. But there's a chance that it could cure them 100%, so that's why they don't readmit as much. That's my working theory, at least. And then prior visits impact on the right, you can see that 6+ visits is a 79.5%, and then it drops down to 64.3%. The lessons learned, we learned the Agile Beam framework forced us to revisit business questions after our initial EDA, as we had to revisit our the questions due to some confusion with what we were, or what would we have to do for our data. Our star schema grain is critical in creating a successful data warehouse, as we could see. We did change it because at first it was overlapping interest of fact, readmission, and dim underscore n counter. Feature engineering in the silver layer improves dashboard expressiveness, as we could see from prior visits, medication complexity, and the aging by group. It was very effective. And then data quality is not binary. And yeah, that's that. We're going to just go through, these are all the graphs individually, just so you could see it a little better. And then I'm going to show you the report that we run to. I'm going to scroll down. Feel free to review this in the portfolio folder. It is underneath. Here, let me pull it open. It's going to be underneath Readmission Data Warehouse Spring 2026. So this is the dashboard, and these are the insights, the main insights, as I've gone over today. And then these are all the queries we used, and then we also got the pictures and our reference, where the data set came from. There we go. But yes, thank you for listening to my presentation on hospital readmission analysis using Python, Tableau, and BigQuery. And I will see you guys next time. Have a good one.